Very good evening, everyone. Very good evening, everyone. I'm really happy. This is our 15th webinar for this year. I welcome all the participants for their wholehearted support in ensuring growth of our federation to the national level. So let me first say a few words on the activities of our federation. Then I will introduce our speaker who will deal with the subject. Actually, what we are going to hear today, we have already been conducting some more webinars on power quality, especially harmonics. But in this webinar, we will be knowing the fundamentals. You are aware that we are already knowing the non-visible pollution like air pollution, water pollution, everything is we are accustomed with. But these are invisible pollution, the harmonics, how it affects your own equipments, your own safety devices, as well as the grid, and also the neighboring persons who are not having any harmonic devices. So these have become an issue. So how to mitigate these harmonics and eliminate all its ill effects to safeguard our equipment, people, as well as our protection scheme that will be dealt with by our speaker. Before that, let me introduce ourselves. That is National Federation of Engineers for Electrical Safety. Am I audible, Lakshmi Ma? Am I audible?
Sir, yes, sir, you are audible, sir.
Yes,
You are
sir,
audible.
audible.
Thank you. If I'm not audible, please intervene because, okay.
Yes, sir, you're audible, sir.
Oh, thank you. So we are creating awareness on electrical safety. Our purpose is to make every electrical installation free from accidents and fire. So we are fighting today for a better tomorrow. You also, all of you may be aware, anyhow, it's my duty to explain, to say a few words on our mission and vision. So our vision, as you know, is to make every installation free of accidents. It's a dream, but dream should come true. So the accident could be either electrocution and fire due to short circuit. So we have to increase the reliability of the electrical installation so that we can contribute to the nation by saving life and property and supporting a sustainable development the country aims now. So in order to achieve this vision, what we are doing, what are the present mission that we are having is, we will try to achieve through the organized programs. For example, we are getting accreditation for the product, that is personal certification has already begun. We are giving training to the people. The aim is to provide personal certification. We should focus on electrical safety. The people who are all involved are the designers, manufacturers of products, installers, there is contractors, maintenance, we call it as a verifier or safety auditors. So these are the main three things that we have to empower them so that a right installation, a safe electrical installation is put in place so that people can readily adapt it and minimize the accidents. So we have started the training for achieving the certification scheme through the professional certifying bodies, and we are on the way. First thing, we are providing training to the trainers, and then we are going to deploy those trainers at the disposal of professional certifying bodies. We do not have any, you should not have a conflict. We can't select our by conducting examination on our own. To avoid conflict of interest, we have entrusted this job as per IEC 17024 that will be vested with the professional certifying bodies. So these are the mission and what we are doing. So we have conducted a lot of webinars. I think more than 100 webinars have taken place. And there are people who have been benefited or appeared, participated in these webinars are more than 30,000. So it's a really important achievement that we have done for the past 1 year. The previous year, we conducted webinar seminars, direct workshops on several important cities across the country. 17 webinars we have conducted. So we are having training division, product division, standards and regulations. The training is well supported by the Bureau of Indian Standards, especially the electrical safety and use of BA certified products is of paramount importance. So you can become, or you can ask your friends to become a member. There are 3 categories of members as of now: individual member and corporate member, as well as MSME. So these people can get benefited by this NFE. We are having a portal. You can log in and know the blogs. We are having several blogs to address the important issues. Those blogs are created by the experts from and among our group. So now this NFE is spearheaded by our president, Mr. Gopa Kumar. He is an International Electrotechnical Commission member. He is having a rapport with the international members on standards formulation, especially International Electrotechnical Commission. So with his leadership, we are bringing with the founding members. I am the General Secretary. I am Apau, the General Secretary of this National Federation of Engineers for Electrical. Now I am going to introduce our presenter of today's webinar. It's nothing but Mr. Abhishek Kumar Singh. He is the Secretary of our National Federation of Engineers chapter, Delhi chapter. He is also the AGM Electrical PC Design Private Limited, New Delhi. He is a consultant. Their group is a consultant for engineers, hotels, car showrooms, and warehouse house projects. They have a client base of Hero Motocar, Maruti, Ashok Leyland, Marriott Hotel Group, Amazon, Haldiram, Flipkart, CK Birla, etc. So he is having a wide exposure of power quality because he is dealing with all such people who are always having what you call the non-linear harmonic producing generating devices. So let us hear his wisdom to learn something on power quality. His purpose will be concentrating on the fundamentals, and mitigation will also be dealt with. Now I will ask Mr. Abhishek Kumar Singh, sir, please, it is your turn. You can share screen and it's your turn. Thank you so much all the participants. Now you will come in. I will stop my sharing.
Good evening.
Then you can
Good
stop
evening.
my sharing first, then you can.
Yeah.
Uh,
Yes, sir.
Okay, fine.
Good evening, all of you. So
Good evening.
today we are here to discuss a very important topic. Am I audible? Am I audible?
Yes. Now, please.
Okay.
Now it's
Okay.
audible.
Thank you. Yeah. So my screen is visible to all.
Sir,
screen is
yes, sir,
visible?
it is visible, sir.
Okay. Very good. Okay.
Yes, sir, it is visible.
Yeah. So basically, we are here today to discuss a very important topic, which is basically power quality. So as we all know, that harmonics plays a very important role and very vital role in today's era. Okay, so basically, first of all, we have to understand that what is harmonics. So basically, the point is that we are
Mr.
having a
Mr. Abhishek
yes,
ji,
sir.
please hold the mouthpiece still closer so that the voice can be still audible.
Okay, sir. Now it is audible.
Yes. Now it's okay. In the same position.
Okay. Thank you. So basically, when our fundamental waveform, which is of 50 hertz, because in India we work on 50 hertz. So when our fundamental waveform gets distorted and converted into an integer multiple of the fundamental waveform, so it can be 150 hertz, that is the third harmonics, or 250 hertz, that is the fifth harmonics, or seventh harmonics, or 11th harmonics. It could be anyone, okay, depending upon the integer value of that harmonic. So, if we overall see that the harmonics, if suppose there is an industry which is producing harmonics, so it is not polluting that industry only, but it is polluting the nearby industries also. So in these slides today, in this topic, so we will understand about how it is polluting the environment, how it is polluting the nearby, you may say, the industries, and how we can cure it, and what is positive sequence, negative sequence, zero sequence, because there are multiple things inside the harmonics. So one by one we will understand all those things. So let's come, and the most important thing is that the harmonics comes under the code of IEEE 519, which governs like which is having plenty of information about the harmonics. So basically, first of all, we have to understand that what type of load generate harmonics. So if we see the television, computer, IT loads, AC, DC drive, frequency converters. So if we see it, then we understand that these all are non-linear loads. Non-linear loads. So it is not a linear load. Linear load means linear load means, so basically there is a voltage and a current. Okay, VI curve. That that we all know. That the load which follow Ohm's law is called as linear law, linear load. This we can say, but this is not applicable to all light, like it is not applicable to the motor, because in the starting of the because in the starting of the motor, if if you will see that the starting current is too high, okay, so so that is not producing any kind of harmonics. So it is not applicable to all, but it is applicable to 90% of loads, that we can say that the loads which follow Ohm's law are linear loads, and the loads which do not follow Ohm's law are called as non-linear loads. So basically AC drive, DC drive, frequency converter, rectifier, induction furnaces, UPS, and CFL, and all those are basically non-linear loads which are producing harmonics. Now, harmonics, as we discussed, that harmonic can be third harmonics, fifth harmonics, seventh harmonics, 11th harmonics. Okay, so we will understand in the next slide that what is basically positive sequence, negative sequence, and zero sequence, and how we can calculate that which type of harmonics shall be generated from this type of drive. Now, basically there is a formula, if you will see, K into P plus minus 1. So P is the pulse. If suppose we have a VFD, so VFD are having a converter and a inverter. Okay, so in that case, if you will see, so VFD will be having certain pulse, like it can be having 6 pulse VFD, 12 pulse VFD, or 24 pulse VFD. But in industry, generally we use 6 pulse VFD. 12 pulse also we use, but the most common is the 6 pulse. Okay, so if there is a 6 pulse VFD, then which harmonic will it develop? Like, will it produce third, will it produce fifth, will it produce which kind of harmonic will it develop? So we'll understand from this. So just put 6 at the place of P. If you will see, this is P. Okay, so 6 plus minus 1. 6 minus 1 is equal to 5, and 6 plus 1 is equal to 7. It means it will produce fifth and seventh harmonics. But it will also produce 11th and 13th. How? If we will put the integer value in this K. So 2 into 6 plus minus 1, that is 12 plus 1 and 12 minus 1. So it can produce either 11 or 13. It can produce either 5 or either 7. Okay, this will depend upon the OEM. Suppose if we are purchasing from ABB, then rotation can be something different. If we are purchasing from Schneider or anyone, okay, so that will depend. So it can produce anyone, like 5th or 7th, 11th, or 13th, like this. And most important thing is that the magnitude is inversely proportional to the order. So the point is, higher is the order, lower is the magnitude of the harmonics. It means the lower order harmonics are more dangerous as compared to higher order harmonics. This is a very important, that lower order harmonics like third harmonics, fifth harmonics, seventh harmonics, they are having the high magnitude as compared to the 13th order, 17th order, or 19th order. That's why we always try to cater that we should control what third, fifth, seventh. These are the most common, as you all have heard. I believe most of us are the industry experts, so definitely you have heard about it. Now, how to find the sequence of the harmonics? So basically there are three type of sequence. One is the positive sequence, negative sequence, and zero sequence. How we will find that whether it is positive sequence or negative sequence or zero sequence? And we will also understand about this, that what is positive sequence, what is negative, and what is zero. So we will understand about this. So you can see here, if the harmonic order is 1, so this is basically the fundamental frequency. Okay, 1. Then it is a positive sequence. If the harmonic order is 2, then it is a negative sequence. If the harmonic order is 3, then it is a zero sequence. So generally, what we will see that in the rotating devices, we will find positive or negative sequence harmonics. In rotating devices, I am repeating my word, in rotating devices, generally we will see positive and negative sequence, and which does not rotate, in those we find zero sequence. So generally in single phase load, generally I'm not saying in all, generally in single phase load we find zero sequence harmonics, which is also called as triple N harmonics. Triple N harmonics, if you've heard about the word triple N, so basically triple N means which is divided by 3. So 6, 9, 12 all can be divided by 3. So these are all the triple N harmonics also, and it is also called as zero sequence harmonics. So I believe this is clear to all. And there is one more point, that in case if you want to find directly that whether it is positive or negative or zero, so it is very easy. You just have to put the number, just put 1. So 3 into 1 plus 1 is equal to 4. So 4 is the positive sequence harmonics. Just put 1, 3 into 1 plus 2, it means 5. So 5 is the negative sequence harmonics. 3 into 1 plus 3, it means 6. So 6 is the zero sequence harmonics. So let's come further. I believe this is clear to all. Yeah. So now we will talk about the harmonic spectrum. So as I discussed in the previous slide about the magnitude, so we will understand here that what was that term. So if suppose we have a 100 kilowatt 6 pulse 0.7 power factor DC drive, so we will find the current of this. So this is basically P is equal to root 3 VI cos phi. That is the simple formula what we use. So basically the current is 200 ampere. Now the fifth harmonics in this is 40 ampere. How? Through this formula. IH is equal to I1 by H, and I1 we have calculated from this. So fifth harmonics will generate 40 ampere, and seventh will generate 28.6, 11th will generate 18.2. So you can see easily that fifth is 40 ampere, magnitude is high, this magnitude is low, this is low, this is low from this. So the magnitude is getting lower from 5th to 19th. That's why we are more worried about the about the lower order harmonics. That means 3rd, 5th, 7th, 11th. Now harmonic order and phase sequence, as we already discussed about this, that basically the harmonics order has a particular phase sequence relationship with the respect of, because when we are discussing something, so it always should have a fundamental. Okay, it always should have a reference. So the reference is the fundamental, that is the 50 hertz. That's why we are saying third harmonics. What is third harmonics? So 50 multiplied by 3 is equal to 150. So the reference point is the 50 hertz. Now, how to determine the phase sequence of each harmonics? As we discussed, so I'll just tell you that whenever there will be an anti-clock rotation, then that harmonic will be, that sequence will be positive sequence, and when there will be a clockwise rotation, then this will be a negative sequence. This you can note, or this I believe you must know this. Okay, so if you will see in this, basically this is the y, this is the reference point, and this is the angle 120 degree, this is the 120 degree, and this is the 120 degree. So this is the fundamental. Okay, so basically all are the three phase, and three phase are divided by each other from, are separated by 120 degree angle. Now this is the second harmonics. In second harmonics it is 240. 240 means negative. Now we will understand about the third harmonics, third sequence, not harmonic, sorry. So basically about third sequence, so the difference will be 360 degree. So 360 degree means from where you are starting, you are coming at the same point. It means all the harmonic current which will generate in zero sequence will be in the same phase. So this generally produces in the single phase load, and all the current will travel in into the neutral, and the neutral current will go into the source. So our source neutral will get overheat along with the core of the transformer. So this is, you may say, negative harmonics, and zero sequence harmonics are more dangerous as compared to positive, because it because if the neutral is getting overloaded or overheated, it means there is a presence of zero sequence. In case if our motor is not moving properly, it means there is a negative sequence, because negative sequence will always oppose the harmony. Now if you will see from this slide, this is about the third harmonics what we discussed. So this is basically a fundamental, and then this is the R phase current with this third harmonic component. So this is basically, this is. So from the IRMS value, as you know that the IRMS, okay, so from the IRMS we can calculate the total current of this. So the total current will be this. So this is basically the final value which will travel into the neutral and will go up to the source and will definitely affect the entire system. Now the characteristics of the harmonics. So if of the sequences, so basically positive sequence, negative sequence, and zero sequence. So positive sequence, there will be a skin effect. In negative, there will also a skin effect, but the skin effect will be higher in these both cases. So this aids the fundamental, this opposes the fundamental, which I already told in the previous slide that it will opposes the fundamental. It means if the motor is rotating, so it will try to block the motor. So that's why the motor speed may reduce if there is a negative harmonic. And zero sequence accumulates into the neutral, which we already discussed. Now, as we discussed above, skin effect. Okay, so what happens when our, because as you know that the harmonic current travel from load to source. If there is a load, if there is a VFD and harmonic is generating there, so that harmonic will try to tend to travel up to the source. Why it will travel up to the source? Because source is the low impedance, because source is having a low impedance. As you know that we are having a transformer. If suppose there is a transformer of 2.5 MVA, then the impedance will be 6.25% only. So the impedance is very less. So that's why it will try to move up to the source. So when it will go up to the source, so it will travel to the same conductor from where the current is coming. So this will definitely make a, you may say, heating in the conductor, and there will be a lot of resistance inside that, due to which what will happen, the effective area for the current will reduce. So R is equal to rho L upon A. This we all have read. Okay. If the resistance will increase, then the effective area will reduce. So if the effective area will reduce for the current, so current will not travel from the inner part of the conductor. It will travel on the surface of the conductor. So when the current travels from the surface of the conductor, it is called a skin effect. Now this is basically, if you say that the fundamental frequency, this is basically green one is the fundamental frequency, and then we are having harmonics in the form of this, and they are having sum. So from the IRMS we can find the total value of the harmonics. So if you want to find, then it is very easy, that you just have to do the square root of all the harmonics, like I1 square, I3 square, I5 square, and just do the under root of this, and whatever the value will come, just divide it from the fundamental current. So the percentage harmonics will come out, that we what we call it TSDI. So that we calculate from that formula TSDI. Now disadvantages of harmonic in a system. So there is one more thing which I would like to tell, that always try to place the drives or non-linear load near to the source, because if you will place the non-linear load at the end of the panel, then what will happen, it will travel in the entire system, because it will travel up to the source, so it will travel in the entire system. So if it is closer to the load to the source, then it will not impact the system much. But if it is very far away from the load, then from the source, then it will definitely affect your system. So as we discussed, that increasing heating in the motors, neutral current will increase, and communication and control system, definitely it will impact. Then the capacitor failure, this we will understand in our further slides, that why capacitor fail if there is a presence of harmonics. And this is the reduced system efficiency. Yes, because there is a lot of resistance, so there will a lot of losses in the system, which will definitely reduce the system efficacy. Now, effect of harmonics on productive relays. So what happens? Suppose we are having a fundamental frequency, then we are having multiple harmonics, and then this is the harmonic, which is the, you may say, the resultant harmonic, which is a combination of fundamental as well as the harmonics. Okay. So now we have set trip value of the frequency, that it should trip if the at this value, at the peak value, but due to harmonics, peak is not coming. So due to which our breaker or whatever we have to trip, that will not trip. In this case, the magnitude is high, due to which if we have said that we have to trip at this point, but it will trip again and again. So this will definitely make a nuisance tripping. Now, how to mitigate harmonics? So there are multiple ways to mitigate the harmonics. So first of all, as we discussed, the whatever the sources of harmonics are there, like the whatever the loads are there, just plan to put near to the source. Second point is the harmonic filter. So we can plan to have harmonic filter. So harmonic filter can be passive filter or active filter. So we will discuss both in our further slide, that what is passive filter and what is active filter, and which one is better to have in the system. And then implementing harmonic mitigating equipment. So this is almost same what we discussed. So now, how active filter? So if we have a active filter in the system, so how it will improve the system efficacy? So suppose this is a load current with harmonics. This is the centrally supply current, and this is active filter. So these are the harmonics which is producing in the system. So what it will do, you may see these are the harmonic currents. These are the harmonic currents. So what it will do, it will inject the same into the system in mirror image. It will inject the same into the system in the mirror image and will nullify the impact of harmonics. So the final resultant will be this. So we will get the same what we want to achieve. So this is the advantage of active filter to have in the system. Now current harmonics without active filter, as we've seen. So there are multiple, you may say that fifth harmonic, seventh harmonic, 11th harmonics. And then after applying the active filter, all are almost nullify. This is the same waveform. So this is, you may say that this is a very much distorted waveform, but after placing the active filter, the waveform is almost sinusoidal, because this is our basically primary, this is the main goal, that to make the waveform sinusoidal, so that the system will run efficiently and we can reduce the losses from the system. Now basically the benefits of this active compensation. So basically, first of all, the first thing is the real-time compensation. So active filter compensate real time, means like wherever it is generating, it will immediately release the mirror image of that and will definitely nullify the impact of that. So there are multiple, you may say, advantages of this active filter into the system. So it can filter up to the 51th harmonic, and this will take very less space into the system because they are just a box type system. So you can place it into a very small space instead of the capacitors what we have, because for capacitor we have to place the huge panels. So definitely we don't require in this. And the real response time is very less, as you can see, it's less than 2 milliseconds what we have in the thyristor base, because in thyristor the time is almost 20 milliseconds, and in the capacitor which is almost go too high if we are having contactor based capacitor. Then basically we have a automatic hybrid panel, correction panels. So basically what is this? So with capacitor we put contactor and it will controlled by active filter. So this is basically combination. This is, so you may say it is not completely active filter panel. This is partial active filter and partial passive. So it will reduce the cost of the panel, because active filters are quite costly. So if you, because we have to make the cost efficient also. So if you want to make cost efficient as well as effective system which can work very fast, so this is the best solution to have right now nowadays, that we can have the capacitor with contactor and can place the active filter with that. So the active filter will take care of the if suppose you may say that the requirement is 225 kVAR. So what the active filter will do, it will switch on 200 kVAR contactor based capacitor and will provide 25 kVAR from its end. So what will happen? So the 25 kVAR, it will immediately send it 25 kVAR. So in case if the further requirement is 245 kVAR, so it will keep 200 kVAR remain on and will provide further 20 kVAR from its end in less than 2 milliseconds. So the improvement is like it is just improving the power factor very fast, and it is killing the harmonics also, nullifying the harmonics also. So that depends upon the design, that how we are designing it. So that all depends on that. Now basically there is a case study regarding the harmonics. So this is regarding a paperboard manufacturing industry. Okay, so there was a load of motor, and the entire plant was not having any non-linear load. All the loads was linear. But what was happening? Their capacitors was getting damaged again and again. So they were quite tensed. So when they do the root cause analysis for this, that why the capacitors are getting failed. So basically what they have found, so there is a industry near to them which is a rolling mill industry. Okay, and there is a furnace basically, so which is producing lot of harmonics. So uh, that harmonic, because uh, that harmonic was basically attacking the capacitor. How? Because when you will place capacitor without any reactor, so what will happen, that if you have heard about xc is equal to 1 upon 2 pi fc. So when the frequency will increase, so its value will decrease. So basically xc is a sort of resistance. So that resistance is getting very low. So that's why harmonic, because harmonic current always tries to have a least resistance path. So it was finding that path, a least resistance path. So that's why the capacitor was getting failed. So it's a very good case study actually. So it means that why we are saying that, not only because if we are producing harmonics, so it means we are not polluting our system, we are polluting other system also. So government is quite active now, and just planning, because in multiple states like in Tamil Nadu, in Maharashtra and other states also, it is compulsory to control the harmonics, voltage harmonics as well as current harmonics. Now let's come on the second topic of this presentation, so which is power factor. So I believe most of us know about the power factor, that what is power factor, as we all pay our electricity bills. So earlier when we pay the electrical bills, so it came into kilowatt. I believe this is almost 10 or 12 or 15 years back. But now the bill comes in kVA. So kVA is basically including the power factor. So now government is saying, okay, if your power factor is low, then you have to pay for it, because it is increasing the capacity of the source from where the power is coming out. If you will see, if suppose we have a load of 1000 kilowatt and power factor is 0.8, then kVA required is 1250 kVA. Why? Because 1000 divided by 0.8, as you all know. And if we improve power factor to 0.99, then kVA required shall be approx 1000 kVA. So this will be sustainable. If we improve the power factor, so this will be sustainable use of energy and will reduce the fossil fuel demand of the nation. As we all know that fossil fuel is getting depleted very fast, so we have to take care of this. So power factor, to maintain the good power factor, even like government is saying that you have to maintain 0.9 or 0.95, but you should maintain 0.99. Always maintain 0.99 through either you may place active filters, you may place hybrid panel, whatever is the best solution to your plant, your industry, but have to maintain 0.99 power factor, which is very important. In case if you will not maintain it, then definitely government is going to plan penalties on you, and which is right now, if you will, if the power factor is less than 0.9 or 0.8, then penalty has to be imposed, like government is imposing the penalties. If the power factor is low, like 0.8, then what is happening? Like if the power factor is 0.8, then the requirement is 1250 kVA. So when the requirement is 1250 kVA, then the cable size will increase, bus bar size will increase, breaker size will increase. So overall system cost will increase. So the losses, which is equal to P is equal to I square R, as we all know. So the more current will flow into the system, so more losses will be happen into the system. Now, basically, this is kVA, this is kilowatt, this is the kVAR. So what is kVA? So kVA is basically apparent power. What is apparent power? Apparent power is the combination of reactive power and active power. So what is active power? Active power is basically the kilowatt. So the load, because every load is in kilowatt, whether like we are having a motor, so it is in kilowatt. Okay, whatever load it is there, it will always be in kilowatt. Like we are having a bulb, so it is in watt, like so 100 watt, 200 watt, whatever it is there. And then we are having reactive power, which is kVAR. So when we use kVAR, so basically when there is a motor load and when it get starts, so it requires magnetizing current, magnetize the core. Okay, so for that magnetization we require kVAR. So basically, the power factor is always off of load. Source is not having any power factor. Power factor will always be of load. So that power factor can be 0.8, 0.9. That OEM will decide whatever that how they are making it. Because if you will see the LED bulbs, on the LED bulb it is mentioned 0.9 or 0.95. So these all things. So the power factor will always be of load. So OEM has to decide that how much will be the power factor. But our point is that we have to control this. How we will control this? We will not take it from the source. We will inject it from internal system through power factor panels. Now what is active power? Active power is basically to generate electromagnetic field for the operation of inductive load such as motor, as we said earlier. Active power is basically a true power which actually do the work, and apparent power is the vector addition of active and reactive power. Now basically, as you all know, that as we discussed, if suppose we have to run a load of 100 kilowatt and power factor is 0.97, then 103 kVA source load is required. And if suppose the power factor is 0.8, then 125 kVA is required. So to run the same load, what activity we are doing? We are running the same load. We are running 100 kilowatt of power. But if the power factor is 0.8, then for to run that 100 kilowatt, we require 120. Means it means it means it means 25 kVA extra power. It means 25 kVA extra power we are producing. It means 25 kVA extra power we are producing from the source, which is which is basically wastage for us, and we are paying for it. So if we don't want to pay, then we have to improve the power factor. Now power factor triangle and power factor. So basically this is the reference. So as you know, P is equal to VI cos phi. So for the single phase, and for the three phase, P is equal to √3 VI cos phi is the formula. So how to calculate? Cos phi is equal to kilowatt upon kVA. So whatever is the kilowatt, or you may say kVA is equal to kilowatt upon cos phi. So kilowatt is, if suppose like we discussed that kilowatt is 1000 and divided by 0.8, so it is 1250 kVA. So whatever it is, so it can come from this formula. So this is basically the triangle. So if you will see, so if this angle is increasing, so this VA will increase. So this is cos 0 and this is cos 90, and cos 0 is equal to 1 and cos 90 is equal to 0. Cos 0 is equal to 1 and cos 90 is equal to 0. So our motto, our intention is that we have to keep this angle as minimum as we can. So this we can do by improving the power factor. So this can be done either putting power factor panels or capacitors and all those things. Now this is a table. If you will see, if suppose our initial power factor is 0.8 and we want to achieve 0.95 and our load is 100 kilowatt. So you will go, you will see this table. So you will come on this point and you will see that this is 0.421. It means that to achieve 0.95 from 0.8, we have to multiply the 100 kilowatt load by 0.421. It means we require 42 kVAr power to improve the power factor, 40 kVAr extra power. Now, how to improve the power factor? So power factor can be improved by placing the capacitor, by having the optimized motor load. So optimized motor load means if suppose the requirement is 50 kilowatt, then need not to have the 80 kilowatt or 100 kilowatt motor. If the requirement is 50 kilowatt, then buy 50 kilowatt only. Because otherwise, if you will buy the high, big size motor, then it will take the extra magnetizing current, which require extra kVAr. So that we have to either we have to produce or we have to generate from our end, but this is definitely a cost. Then use of VFDs. So as we know that VFD produce VFD control the power factor, but also produces the harmonics. So to control the harmonics, we have to that we have already discussed, that to control the harmonics, like we are having multiple system, how we can control it, and replacing the inefficient equipment, like whatever the equipment which is very old or that, so that we have to replace. If we replace that, then like the power factor can be improved, like because the modern equipment are having good power factor. So one thing you have to take care whenever you buy something, or if you are a consultant, if you are a contractor, if you are because we all are industry experts. Okay, so whenever we are buying something, we have to take care of this. We have to take care of power factor, we have to take care of harmonics also. Whenever we buy something, always, if you are buying an LED, always take care that the LED should have less than 10% harmonics. If we are buying any equipment, then the power factor should be more than 0.9. Now this you can see. So APFC panel is basically, this is a power factor, this is a reactor, and then this is a capacitor, and this is a this is a contactor, and this is a thyristor. So basically capacitor can be controlled by thyristor, capacitor can be controlled by contactor. But the point is that the you may say the correction time of thyristor is very fast. However, the correction time of contactor is very low. Very low means it's in seconds and it's in milliseconds. But the problem is thyristor are having heating issues. So if you are placing a thyristor, then you have to provide it a cool environment. Like you have to place it in a room and you have to provide some AC or proper ventilation in that, then only it will work efficiently. And it depends on application also. If suppose there is some residential application, then we need not to provide this. If the residential application is there, so we can provide this type of capacitor. But if there is an industrial application, then definitely we have to provide this sort of thyristors, because industry, if suppose some big motor load they have started, so the motor will magnetize its core. So if the core will get magnetized, so the power factor will get down, and the correction, if suppose we have provided contactor base, then the correction time will be high. In that case, our MD, maximum demand, will shoot up. So to control that, we have to provide thyristor based, or we have to provide hybrid panel that we already discussed. Now, there's a one more important point, that as you all see, that this is a reactor. What is the use of having reactor here? As we discussed earlier, that reactor was placed before the capacitor. So what is the use of this reactor? Now, as you can see, that why we use reactor before capacitor. So XL is equal to omega L is equal to 2 pi FL, and XC is equal to 1 upon omega C is equal to 1 upon 2 pi FC. So basically, if you will see, if the frequency, if the if there are harmonics in the system, if there is a fifth harmonic, so it means 250 hertz. So when there is a fifth harmonics, it means the capacitor value will be very low because this is inversely proportional. So this will be very low. So if this is very low and it is not there in the system, the harmonic current will attack it, and your capacitor will get damaged. Now, if we are having this XL is equal to omega L 2 pi FL, if we are having inductor before this, then what will happen? If the fifth harmonics is there, then there will be 250 hertz. So the value of this will increase. So this will increase. So if the harmonics will try to come here, so it will definitely will not be. So the harmonics will not be able to enter this, and it will go back to the supply. Now basically this is the capacitor. So normal capacitor. So this is basically what we have understood above is basically is a LC network. This you can see this is a LC network, L and C network, which we place before the capacitor. So this is the reactor and this is the capacitor. Because we can't, because conventional capacitor cannot be used. In case if we use it, then this will definitely get damaged. So we have to use the filters before that. So what filter is doing? Filter is suppressing the harmonics. It is not so that we need to understand. It is suppressing the harmonics. It is not killing the harmonics. Only active filter can kill the harmonics, but reactor cannot kill the harmonics. Reactor can only suppress the harmonics. So this is a very important difference in between these two. So network with harmonics, if you will see, if there is a non-linear load, so what will happen? So there is a harmonic, so the harmonic is there, and harmonic will trend to supply. It will not come here. Why it will not come here? Because there is a reactor. Because we have placed a reactor here. If suppose it is not there, then what will happen? Current will flow like this and will go into capacitor because it is a least resistive path for this. But we have inductor, we have reactor, so it will not come into this. Now we are having the harmonic filters. So for harmonic filters, we have already studied that like there is a FR. FR is basically you may so filter has a unique self series resonance frequency, which is FR. So FR is what? So below that FR, the filter will act as capacitive, and above the FR, filter will act as inductive. So it means, so the frequency, if there is a frequency, if there is a high frequency, then it will act as inductive. If there is a low frequency, then it will act as capacitive. This you can see. Now classification of harmonic filters. So harmonic filters can be classified into multiple types. So one is the detuned filter, then tuned filter, then active harmonic filter, and hybrid harmonic filter. So what is detuned filter? So detuned filter comes into two types. So one is the 7% and another is the 14%. So we will discuss both of these, that what is 7% and what is 14% and what is the use of this. And one is the tune filter. So basically tune filter, we have to tune as per according to the harmonics requirement. So whatever harmonics we want to kill, we can tune that we want to suppress, we can tune that, like on fifth harmonics or seventh harmonics or 11th harmonics. But in case of detune filter, we need not to have the harmonic study. We can plan it. If suppose there is a if suppose the harmonics is fifth harmonics or more, fifth or seventh or 11th, then we have to place 7% detune filter. If the harmonics in the system is third harmonics or more, then we have to place the 14% detune filter. So there is one more important point. So there is one more important point regarding the filter. So when we buy when we plan to have a capacitor, in that case, if suppose there is a capacitor 100 kVAR, okay, so we have always the voltage, because capacitor comes into three voltages. One is 440 volt, one is 480 volt, and another is a 525 volt. So capacitor should always be of heavy duty. Why? Because if we are having a detuned reactor, detuned filter before the capacitor, so due to the detuned filter, the voltage at the capacitor will increase. So due to that increase, if suppose there is a capacitor 100 kVAR, then the voltage at the capacitor will increase. suppose if we will place the 440 volt capacitor along with a detuned reactor, due to high voltage the capacitor will fail. So that's why the capacitor should always be of high voltage, like 525 volt we have to plan. So this we can see that this is FR, this is the FS. FS is basically the system frequency, and this is the tuning factor. If you will do this, like if you will divide this like the 50 hertz divided by this p means 7 or 14, whatever it is there. So it is 189 hertz. 189 hertz means, so whatever the frequency which is above 189 hertz, it will block all those frequency, but it will not block below 189. So that's why we have told in a earlier slide, in previous slide, that if suppose there is a third harmonic in the system, then this will not cater that, because it can only cater all harmonics which is 189 hertz or above. So for third harmonics, that means 150 hertz, we have to plan 14% filter, which is able to cater 130, which is able to cater 134 hertz. Any frequency which is 134 hertz or more, that can be suppressed by 14% detuned filter. So you can see here for IT-based industries, 14% detuned filter. This is basically 134 hertz. So any frequency which is more than 134 hertz can be suppressed by 14% detuned filter. So whenever you are going to design your system, then you have to take care of this, that how much load is the single phase load. So if there is a lot of single phase load, then definitely you have to plan for 14% detuned filter. Now the summary, it is seen that introduction of capacitor, like what we have introduced the capacitor in the non-linear loads, so the overloading will definitely increase. So that's why we require a detuned filter with that, just to avoid the overheating and to avoid the damage of the capacitor. So thank you very much.
Thank you, Abhishek ji. It's a very good presentation by you. You have explained everything about the fundamentals involved in harmonics analysis. It's a very big
Yes,
subject. Actually, it requires waveform analysis using Fourier series. Strictly speaking, there is no such even odd or triplet harmonics. Actually, waveforms will not be like that. It will be something like ECG, X-ray. You have to simplify that and study that. We are using Fourier series analyzing with reference to the known sine waveform. So in short, the harmonics is distorted waveform. Nicely you have explained. Also, you have pointed out on important thing that implementation. We know the problem and the issues of harmonics. Is it implemented? Actually, strictly speaking, as you said, in Tamil Nadu and Maharashtra, they have come out with some implementation model. They have also, the regulatory commission have also notified, but actual implementation is yet to take up. There are still some difficulties in measurement, but we need not wait, because it's a headache for the consumer himself. Within the consumer, the compliance with reference to the grid are one thing that can be implemented, but harmonics will make you compulsorily implement it when you find your system goes wrong. That is when you have explained that some mal-operation of devices can occur, and also the other things like what do you call issues like burning the grid and your own equipments. Your sensitive devices may malfunction, especially in hospital locations. There could be a possibility of malfunctioning of sensitive medical devices. So you will be compelled to go for mitigation using active and passive filters. These detuned filters, everything have been explained well. Now I am seeing some questions in the chat box as well as question answer session. First, I would, though we have recommended question answer box, let me see the chat box also. There is one important question in chat box. That is one Mr. I think one question from Suresh Kumar. Sir, Mr. Abhishek, Mr. Suresh Kumar has asked one question
Yes, sir.
where there is humming noise at detuned reactor, that is in capacitor panel at a transformer. So what's the reason? I don't know what's the exact question. It seems that there is a humming noise appearing. Do you
The
want
transformer.
to
Sir,
transformer?
if there is humming noise in the transformer, it means that the harmonic current is going into the core of the transformer. So definitely, when the eddy current and hysteresis losses will increase because it will oppose that. Okay, so it will increase the hysteresis and the eddy current losses. So it will definitely create a sort of humming noise in the transformer if there are a lot of harmonics in the system. So I believe that Suresh sir, I will recommend that please ask someone to have the harmonic study of your plant so that you can get the actual database.
Okay, thank you. Thank you, Abhishek ji. Now we will come to the question answer session. Question Q box. There are some questions from the Q box. I will read one by one. First one is by Mr. Shivendra Sanapati. Are we able to receive PPT also after this? Yes, you can receive. It will be, you can
Yeah,
access it
definitely.
from the NFE website. It is free for NFE members. Another question from Yatala Narendra. How to correct or steps for a procedure to be adopted for power factor correction? How to correct or steps for a procedure to be adopted for a,
So
it seems to
basically,
be a design aspect. Can you go? You
yeah,
can try
no,
to
sir.
explain.
So basically, I will recommend because now you can use hybrid panels. What I will say, because in case if you are using a conventional APFC panel, so what will happen? So you are using 100 kVAR, 50 kVAR, 25 kVAR, 5 kVAR. So there will be lot of, you may say, operations of the MCCB, operation of the capacitor. If there is a requirement of 45, then there is a requirement of 65. So there are a lot of in. So as I told in the slide, if you will use a hybrid panel in which it is a combination of active as well as passive. So you are having capacitor with contactor base, and then you are having the active filter. So in that case, there is because active filtration is stepless. Active filtration is stepless. So what will happen in case if the requirement is 315 kVAR? So only you need to on 300 kVAR capacitor, and just 15 kVAR shall be supplied by the active filter. So the point is that this will reduce the panel size. First of all, this will reduce the maintenance cost of the MCCB, and this will reduce the energy cost also. So this is a very good. So if you will use hybrid panel, so that will be better for you. So this will be almost stepless.
Okay, thank you. Another question from Mahesh Kumar Bashur. If power factor above unity, what is the solution? Client has
Yeah, you have
installed
to.
solar
You have.
power. His case is
Yeah,
client
you
has
have.
installed solar power.
Yeah, if the power factor is above unity in a solar power, it means because it is happening in the it is happening in the night time only. If you will check your system, then it is happening in night time only. It will not happen in daytime because in daytime the cables are in use. So in night time, what will happen? There will be multiple cables. So cables has a capacitance, if you will see. Okay. So cables have a capacitance. So there's a formula of charge QC. QC is equal to half CV square. So there's a voltage also. So when you will see, so it is a square of the voltage. So when the voltage will, when the charge will increase in the system, when the QC will increase, in that case the capacitor will lead the system. Okay. So then, so it means that you may check it, but I'm sure that it is happening in the night time only.
Okay,
So
thank you.
then, so in this case, you have to use active filter or hybrid panel because
okay.
it will not let the system to be inactive in the capacitive mode.
I request the participants to put their question in question answer panel, not in the chat box, so that it can be easy for us. Anyhow, we will try to address the question chat box also, but we will give priority to the question answers. Okay. Another question is from Vishwanath Herer. If voltage harmonics is high, that is 10% current harmonics, 15%, and facing problem of reactor burning, APFC, SFU burning, capacitor bank high current, then what will be the solution? Voltage harmonics, he is referring voltage harmonics, more
Sorry, sir,
than 10%.
can you repeat the question, sir?
Voltage
harmonics is coming in the system.
if the voltage harmonics is
Okay.
high,
So
10% to
basically,
15%.
if you will see, if in the conventional system, what happens? Firstly, we have the voltage, then current comes into picture. But in case of harmonics, what happens? Firstly, we have the harmonic current, then voltage comes into picture. Then voltage harmonics comes into picture. Okay. So the most important point is that you have to control the current harmonics. If you will control the current harmonics, then the voltage harmonics will automatically get controlled.
Okay. Then another question from Govind Jha. How do we know harmonics issue is coming from source or from the building system?
Okay. So is it coming? So 90% of case it will definitely come from the load only, whatever is the load. So for that you need to do the analysis of the harmonics. You have to conduct a harmonics analysis for the system. Then only you will be able to understand that. But 90% of the case it will come from the load only. Whatever is the load in the system, it will come from that only.
Okay. Another question from Murali Mohan Kanagala. When the load is transient, example MRI load, how to handle the harmonics?
Definitely, yeah, you have to plan some active filter.
Okay.
Because to control, look, actually, what we have seen in the slide, to control the harmonics, we have to inject the mirror image of that harmonic. If we will inject the mirror image, then definitely harmonics will get controlled.
Okay. Another question is from Mr. Singh. Mrs. Pallavi Mukherjee. He is our chapter secretary in Mumbai. Hello, Mr. Singh. Many of the admin people are not engineers. How to explain them in layman language about harmonics and power factor so that they understand? Ms. Pallavi, what I can suggest is, if you are in a medical facility, you can be a HR person or administrative person. If something goes wrong with the medical device or some IT device in a computer instruction data center, you ask either in medical instruction, you ask the biomedical engineer. And in engineering or data center, you ask the utility engineer how it can happen. Ask them to conduct a study and put forth their views, how it happened. You can drive them. You need not know about the fundamentals of harmonics. Unless you measure, ask them to measure and understand whether it exceeds the permissible limits. What's the actual, how it is affecting your equipment. Once an equipment is affected, you can symptomatically presume that some waveform distortion have taken place. Simple. It's a waveform distortion which affects the sensitive device first. Okay.
And it will
Another
always
question.
follow the least restrictive path.
So as he said, the least resistant path, the vulnerable things are least resistant path transformer. Transformer, of course, can bear because of this high level of capacity. But sensitive equipment will become the victim in most cases. Okay, we will come to the next question. He is from Sanjeev Kumar. Will installation of PQM meters help in monitoring the harmonics in system? Sanjeev Kumar is from NFE member in Gujarat.
Yes, sir. What is the question, sir? Please repeat.
Will the installation of power quality meter help in monitoring the harmonics in the system?
Yes, sir, it will definitely help to monitor the harmonics. And now we are having multiple devices, we are having multiple meters which actually measure the harmonics. So we are having normal meters also, normal MFM meter which are having the capability to check the TSDI. So you can place that also.
Yes,
And in
it's
the
a,
APFC panel, you have to plan some controller and the meter which will be able to control the initial harmonics as well as the controlled harmonics. So what you are getting from the system, like from the load, and what you are correcting. So that also you can do.
okay, what I can suggest, I can supplement some point to Mr. Sanjeev Kumar.
Yes, sir.
Harmonics measurement, measure and manage is the paradigm for any utility engineer. So you install the meter. Actually, IEEE 519 as advised by Mr. Singh. The measurement is governed, detailed in IEEE 519, where three type of measurements. One daily measurement with short interval of time, 3 seconds. Another is weekly measurements, 10 minutes. So if you install and find the 3 second and 1 week measurement, you will be thoroughly knowing where the harmonics. There are meters which can generate the report. Report generation is also there. You can easily understand where the harmonics pollution is high, whether it is the UPS or it is from the some other sources. We can assess and do mitigation according to the level of pollution. So measurement is a must. That will definitely help. Without measurement, you can't have a proper design also. Okay, we'll come to the next question. Is from Mr. Baluji. What is the acceptable value of voltage and current harmonic level as per standards?
So Baluji, there are multiple things. So it
Acceptable
all
level
depends
of
upon
voltage
the.
and current harmonics level as per standards.
So it depends, because if you will see the IEEE 519, so they have defined it from the multiple voltage ranges. For 100 to 1000, it is a different. From 1000 to above, it is different. So what we are doing, so from 100 to 1000, it is basically 8% for current harmonics and 3 to 5% for voltage harmonics.
I would like to supplement
Yes, sir.
view. That is the meter. The metering protocol is so stringent. With IEC 61000 -4 -30, addition 3 meters have to be used for measuring the harmonic voltage. But harmonic voltage, acceptable voltage is the burden of the grid as per IEEE 519. As per CEA regulation strengthens the implementation by notifying. They have notified. So the voltage harmonics, it is as a result of current harmonics. That is another way. But you should be concerned with the current harmonics level as per standards. As per standards means it's not the individual current harmonic. That is total current harmonics is alone not taken into account. It's a total demand distortion. For example, for every short circuit current divided by the load current ratio, if it is a small ratio, suppose if the short circuit current divided by your annual demand load current is less than 50%, 50, then your norms will be one thing. If it exceeds 50, you can pollute more. So there are several tables for various voltage level that you can go through from IEEE 519 2014. It has been amended recently, that you can go through and you can refer various tables for voltage harmonics, for the ISC by IL level, for the current harmonics, even for the even odd harmonics. There are slabs. Ultimately, the final outcome for compliance is governed by the TDD, total demand distortion. That is your harmonics, that is current harmonics, multiplied by the measured current, fundamental current, divided by the demand current. Demand current is nothing but the annual contract load. That is annual average demand load current. So this is a thing you can refer item. Another question is from
And sir, I believe that sir,
uh,
someone has asked about that the harmonics is coming from outside or inside. So for that, multiple meters are available in the market. So in case of Schneider, so there is a meter ION 9000 series. If you will place that, then you will be able to get the data whether the harmonics is coming from outside or it is generating from the load what you have. So there are multiple ways to find out this.
okay. Okay, you can also contact Mr. Abhishek when doubt arises. One person asked about whether it is within the building or from outside the building. It's a valid question.
Yeah.
You can contact.
Sorry to interrupt, sir. Two people have raised their hands. So should I allow them to talk?
Yes. I couldn't see the
Mr. Balu and
hand
Mr.
raised.
Rajesh Goyal.
All right, fine. Mr. Rajesh Goyal, please. I have not seen your question in the question answer box. Okay, please put your question to Abhishek.
नमस्ते अभिषेक कुमार सिंह जी।
नमस्ते सर, कैसे हैं आप?
फर्नेस के अंदर एक ऑडिट की थी पावर क्वालिटी की, जिसका 4 MVA का लोड था एंड उसके अंदर मैंने HF लगा रखे हैं, एक्टिव हार्मोनिक फिल्टर लगा रखे हैं डेल्टा कंपनी के 600 एम्पियर के। माय प्रॉब्लम इज दिस कि आफ्टर यूजिंग HF माय न्यूट्रल करंट इंक्रीज and neutral harmonic is also increased. What is the reason? Now how can we mitigate?
So neutral harmonic if neutral current is increased, then definitely neutral current has to be supplemented by active filter only, or you can earth it. You can earth the system also. Okay, so if you can earth the system, then this can also help. But
I am done earthing also. Then we switch off the HF. My neutral current is 10 ampere. But when we use HF, we activate the HF. My neutral current is goes to 100 ampere.
Sir, this can be malfunctioning of HF also. First thing. Second point is that because the purpose of HF, the purpose of active filter, because when we are having third harmonics or we are having triple N harmonics, in that case, the current comes into neutral. Okay, so in that case, you have to provide this neutral current into the system. And what type of load it is? What type of load it is?
My load is balanced type and it is a furnace load, 3-phase balance furnace load. But
Single phase furnace. Is it single phase furnace or 3-phase furnace?
For 3-phase furnace, and but neutral. My third
no, is it single phase furnace?
This is 3-phase.
3-phase furnaces.
Yes.
Abhishek, I would like to add one thing. Mr. Goyal?
Yeah. Yes.
Mr. Goyal, what is the location of this active power?
Rajasthan.
Near the transformer or between the transformer and load? What is the location, exact physical location? That is the electrical location. Where it is connected?
Jaipur, Rajasthan.
No. The connection point of active harmonic from the transformer to ME panel or after the ME panel, load side or the supply side, where it is connected.
That is on 415 volt LT side.
After the panel.
My connection is on 33 kV. We have used 4 MVA transformer, 33 to 415, and we use HF on 450 volt.
No. I want to.
There is one point, Rajesh sir.
It will become a very big discussion.
There is one point that how three-phase furnace can generate the neutral current. Then it means there are some single phase loaded which are generating. There are some single phase drives or something like that which are generating the neutral current. Because three-phase current, because three-phase load doesn't require any neutral. So how it will generate the neutral current?
मेरा जो ब्रेकर है ACB डेट इज 4000 एम्पियर, उस पे 3000 एम्पियर का करंट फ्लो कर रहा है। मैंने उसी पर अपना एनालाइजर लगाया था एंड हो सकता है कि नेटवर्क के अंदर कोई 3-फेज का लोड भी हो, सिंगल फेज का लोड भी हो, मे बी पॉसिबल।
क्या होगा मैं बता रहा हूँ, उसमें क्या होगा कि आपका क्योंकि आपका 3-फेज का कॉर्रेस्पॉन्डेंस है, तो वहाँ न्यूट्रल का तो आने का कोई मतलब है नहीं उसमें, ठीक है।
जी हाँ
नाउ द
जी
पॉइंट
हाँ
इज कि आपके यहाँ सिंगल फेज के ड्राइव्स होंगे जिसकी वजह से न्यूट्रल करंट आ रहा है, पहली चीज। सेकंड पॉइंट इज है कि जो आपका एएचएफ है, एएचएफ का काम होता है कि इन केस अगर न्यूट्रल करंट है तो वो एडिशनल उसमें न्यूट्रल प्रोवाइड करके उसको न्यूट्रलाइज करता है। इन केस हो सकता है कि शायद सिस्टम ठीक काम ना कर रहा हो, देन इन दैट केस यू मस्ट फर्स्टली कॉन्टेक्ट ओईएम ऑल्सो, हुएवर इज द ओईएम।
ओके।
ओके,
तो चलो मैं आपसे डिस्कस करूंगा, आपके ना सब नंबर शेयर करके बाद में।
श्योर सर,
Okay,
श्योर
thank
सर,
you.
श्योर सर,
Thank you, Goyal.
you can talk anytime.
We'll go to the next question. It is from Radha Swami. We have a central animal factory and basically non-linear load subjected to sudden heating and cooling of the system. Wanted to know what is the effect of harmonics of this kind. Is it, Goyal, you can, Abhishek ji, a question is from Radha Swami. Yes, yeah.
Yes, sir.
Yes,
Yes,
Radha
sir.
Swami ji, please tell.
Yes, sir.
Yes, sir,
Yeah.
please tell, sir.
Yes.
Yeah, I have put a question in QA, sir, actually.
Yes, yes, sir. Please go ahead with your question.
There is one central animal facility where the system is subjected to sudden heating and cooling. Means like to create the artificial conditions for the animal research center. And suddenly if the temperature rise, heaters will start, coolers will start working, and alternately, like to create the artificial condition of humidity conditions generated, like the animals brought from other countries, and they are doing research on the animal research on the animals. And in that, it's a 2500 megawatt load dry type transformer, which has been fixed. And what will be the any effect of these harmonics in to that particular load, sir?
Can you please repeat your question, please?
Yeah, that
But
load
means
will,
exactly what you want. Exactly what you want to ask. Exact
yeah,
question.
will there be any harmonic effects on the system? That is the
From
as
where?
far as the
From
load
the
is
load
concerned.
to do the load has
No,
any
Abhishek,
do the load has
Abhishek
any
ji.
drive or something like that? Yes,
Yeah.
sir.
No, Abhishek ji, his concern is
Yes, sir.
sudden heating and cooling is taking place. So it's something like a malfunctioning of the control system is due to harmonics. He wants to
Yes,
know.
sir. Yes, sir. Yes, suppose,
that
sir.
is that is what he
Yes,
intends.
sir. Yes, sir.
But
Thank you, sir.
your question requires a critical study. The environment,
Sudden
at the
heating.
location.
Sudden heating. If sudden heating is coming, then yes, definitely there could be harmonics. But you have to check when the heating is coming. At that time, what other loads you are switching on? Is there any
Hello.
non-linear load which is creating the harmonics at that time? And because as we told in the slide that harmonics current will always tend to travel to the source. So when the conductor is having a source current, and the current and the harmonic current will tend to flow toward the source, then there will be heating in the system. So that you need to check that in parallel to that, what other load you are switching on, or is that a non-linear load that we need to check.
Okay. Okay,
Okay,
sir.
sir. Mr. Radhasamy, you have your power quality analysis study that.
Thank you.
And see whether the control systems are getting affected due to the radiation. And that is, radiation means a conducted or radiated emission from these harmonics, whether they are closer by. For example, a PLC panel could be closer to your VFD panel, something like that. You check
Yes, sir.
with the harmonics analyzing people.
Thank you, sir. Thank you, Apu, sir. Thank you,
Thank
Abhishek
you.
Kumar Singh.
Welcome.
Thank you,
Please,
sir. Thank you.
I am going to the next question. It is from, is there any other hand raising? Please lower your hand, sir, Mr. Radhasamy. Please lower your hand. There is one question from Mahesh Gaikwad. What can we do? Different techniques to reduce triplet harmonics. Mr. Abhishek ji, how to reduce triplet harmonics?
Triplet harmonics. Yeah, triplet harmonics is basically generated when we are having multiple single phase loads. So as we discussed, so firstly we have to select the load very wisely. Okay, so we have to check that, like, if we are selecting the LEDs, so in market, if you will see, two types of LEDs are coming. One is with the harmonics, which is less than 20%, another is with the less than 10%. So first is the selection of the load. What is the load that we have to select very wisely? First point. Second point is we can plan the AHF, and through AHF we can inject the neutral current into the system. That will reduce the effect of triplet harmonics.
Okay, we'll move to the next question by Mr. Govind Jha. Does the hybrid filter, that is power factor plus harmonics filter, capacity is defined in running system after the study, or it can be defined in design phase itself?
Yeah,
So-
so basically the design has to be, look, actually if I'll say it, so definitely study should be done. In case if you have to design very fast and if you don't have time, then you can do one thing. On the thumb rule, you can say that if the transformer capacity is 2.5 MVA, okay, so based on that, so whatever the current it is there, so the 15% of that, if suppose a 2 MVA transformer is there and the total current is 2782 ampere, then 15% of that, it means 400 or 450 ampere, you can take as a, you may say active filter 450 ampere, and rest you may say, you can cater into the passive filters. So
Okay.
this is how you can make a sort of combination like that. But I will suggest do the study properly, because that will definitely, because whenever we design something, so that is not for 2 years or 3 years, it is for a long time. So definitely we have to study and design very wisely.
Okay, thank you. Next question is from Ullas Vajre, our Mumbai chapter NFE person. His question is, with KVAH billing, maintaining power factor to 0.99 or use of APFC switchboards are not enough measures for the reactive power measurement. Sorry, reactive power management. What is your opinion on this? So his question is, because in Mumbai, in Maharashtra, it's a KVAH building. In such a building, maintaining power factor or use of APFC switchboards are not enough measure, not sufficient for reactive power management. What is your opinion on this?
So actually unable to get this. Can you please repeat, like, what exactly you want to ask?
With the with KVAH building, maintaining power factor, he suggested to maintain power factor to 0.99. That is why he is asking.
Yeah.
With the KVAH building, maintaining power factor to 0.99 or use of APFC panels are not enough measures. These measures are not sufficient for reactive power management. So APFC
If it is
panels
not
are not
sufficient, then
sufficient.
definitely either it can be under capacity, if we have to, because we have to check that how much is the load and how much is the selection of the capacitor, how we are selecting the capacitor. So that all depends on that. In case if it is under capacity, then definitely it will not be able to cater, like it will not be able to do the correct correction and will not do that 0.99. So that we need to check the inductive load of the system, how much is the inductive load, and then according to that we have to select the capacitors.
Okay. Next question is from Azmat Bhai. What is the correct method of power quality measurements? That is power quality analysis. Is it 24 hours, 48 hours, or 1 week to measure the THD or TDD?
Yeah. So basically, sir, in case if we are doing this, then definitely firstly we have to install the equipment. So whatever is used for the power quality measurement, okay, and then uh, you may say that we have to put it with the high sample rate, so that it can catch all the harmonics, okay, in the system, whatever, by, like, either it is traveling into the system or it is going, like it is coming into the system or it is going out, whatever it is there. And time period, I believe, 7 days, I believe that 7 days it is more than enough, because in 7 days we will be able to operate all the machines whatever is there in the plant.
Okay, I would like to supplement your answer.
Yeah, sir.
I have already told that the regulation has what do you call already recognized the IEEE 519 standards, and they have insisted 1 day measurement as well as 1 week measurement. If
Yes, sir.
any one data goes out of the range, then it will be you will become a non-compliant. So both are to be seen. That is the thing available in IEEE 519 as
Yeah.
well as our regulation is endorsing it. Okay, then I think when it comes to what is one question, I have seen one question, it's not available now. I think Mr. Davis, can you raise your hand so that
Yeah.
you can
Yeah.
unmute,
Yeah.
please,
Yes,
because
sir.
you have not asked question, you wanted to ask question.
Yeah. Good evening, Apausav, and
Good
good evening, Abhishek ji. It was a
Yes,
very nice presentation, giving a lot of insights, a lot of information. So, just to my questions to Abhishek.
Yeah.
Now you told that source also can create harmonics and also load, right? So load part, I understand the VFD, whatever we have at our home is fine. We are safe. But then if it is from outside, that means somebody is putting an EV charging station in my compound or in my location, and people are keep on doing it, right? So is it influencing something to me from the system itself? From the source itself, because
Yeah,
EV
definitely,
charging
sir.
is
It can
always
look
come with the
actually the
harmonics.
tendency of the harmonic current. Sir, basically the tendency of the harmonic current is to, because the tendency of current actually is to take the least resistive path. Okay, as we discussed, because why it always move towards the source, because source is the least resistive path for it. Okay, so in case if because you have seen that there are multiple cards failure happens because of harmonics. Why? Because they are having the less resistance as compared to the source. If we are placing our load just to the end of the system, and the harmonics will travel to the entire loads whatever is connected in between the load and the source, then definitely harmonics can travel in any of the system which is least resistance as compared to the source. So if it
Okay,
is
sir.
this is basically the main reason.
Yeah,
Yes.
I understand. I just want to be clear. If there are many number of EV charging happening in my complex where we have some 100 flats. So is it going to affect me where I do not have anything, but then is it going to affect me because it is coming from source?
Definitely, sir, it can, sir, definitely it can affect, sir, it can affect, but the main point is the resistance. Okay, so
Okay.
because electrical, as you know about the electrical, that if the resistance is low, then definitely it can affect.
Okay.
So, yeah.
Okay. Thank you.
Yeah,
very
sir.
much. Thank you,
Okay,
Apausav.
Thank you, sir. Thank
okay,
you.
Mr. Davis, I
you.
think we have covered all the questions. And can we close? Okay. I think I should thank Mr. Abhishek Kumar Singh for his invaluable presentation that has raised so many questions from the participants. I thank participants also to be kind enough to put forth all their questions frankly. And I hope that the participants would have been benefited from all these questions. With this, I would like to thank the Blue and Gray who has
1 minute.
patiently. I think Mr. Gopa has come. Sorry, I noticed now only. Please, sorry.
I joined
Please,
very late.
please put some words, some advice, please.
So congratulations, Mr. Abhishek. Thank you very much for the support and
Thank
very
you.
nice
Thank you,
presentation.
Gopa.
Lot
Thank
of
you, Gopa.
interaction.
Thank you.
I also request all other members of NFE to come forward with such subjects so that we can make this webinars very much effective and weekly. We can also give this knowledge to several people. The videos will be uploaded in our YouTube channel very soon. And, it will be useful for several people. Thank you very much. Thanks, Apau sir and Mr. Abhishek.
Thank you, sir. Thank you.
Thank you.
Okay, okay. Thank you all. Thank you, Abhishek ji. Thank you, Gopal ji. Thank you all participants. Bye,
Thank
bye,
you.
bye.
Thank you all.
Okay, sir. Thank you,
Thank
sir.
you.